We're going to do number 1 here. Using a coordinate proof, determine if these two triangles are congruent, and we need to show and explain all our work. Okay, we don't know anything about the angles when we're talking about on the coordinate grid here. So to show that these two triangles are congruent, we are going to have to show all the corresponding sides are equal. So let's write down some coordinates here. Let's write down K, J, and L. So K, if you notice, is at -7, 1. J is at -4, 4. And L is at -3, 0. And then let's write down some coordinates over there for RZT. R is at 2, 5. Z is at 1, 1. And T is at 5, 2. Alright, we're going to have to show side lengths, so distance formula, which you've used quite a bit in this class. So let's do on our left triangle first, triangle KJL. We need to do the distance from K to J. So it's the square root. And then I take x1 minus x2, so I'm going to do -4 minus -7 squared plus 4 minus 1 squared. So this ends up being a plus here. So I really get -4 plus 7, which is 3 in parentheses squared, plus 3 in parentheses squared. So that's 9 plus 9, or the square root of 18. And I'm just going to leave it as a square root. But let's do the distance from J to L. So from J to L, I'm going to take -3 minus -4, and I'm going to square it. And then I'm going to take 0 minus 4, and I'm going to square it. So this becomes plus, so this is really 1 squared, -4 in parentheses squared, which is 16. So it's 1 plus positive 16, which is square root 17. And then let's do the distance. Let's do the distance from K to L. So the distance of KL, square root. So from K to L, I'm going to do -3 minus -7 squared. So that becomes plus 7. And then plus 0 minus 1 squared, which is -1 in parentheses squared, and this is 4 squared, and square root around that, so that's the square root of 17 also. So it's actually an isosceles triangle, but we're just going to show congruent sides. So now I got to go over to my other one, which is RZT, and I'll do that work down here. So distance from R to Z. So I'm going to go the square root of 2 minus 1 squared plus 5 minus 1 squared. So that's 1 and that's 4. So 1 squared is 1, 4 squared is 16. So that's square root 17. Let's do the distance from Z to T. So square root of, and I'm going to go 5 minus 1 squared plus the y values, subtract 2 minus 1 squared. The square root of, that's 4 and that's 1, so 4 squared plus 1 squared is, So it'll be 16 plus 1, which is square root 17. And then the distance from R to T, square root 5 minus 2 squared plus 2 minus 5 squared. Square root, this is going to be 3, and this is going to be negative 3. When I square both those, that's 9, so it's 9 plus 9, square root 18. I'm running out of room here, but as you can see, we've got square root 17, square root 17, square, and then another square root 17, pair of corresponding sides, and then a square root 18. Therefore, they are congruent triangles.